Here we go. Algebraic limits 1.4. Whenever you don't have a graph or your calculator, you're going to have to use some kind of algebra or algebraic skill to solve limits. One of the very first things that you should try is direct substitution. That involves just taking the number and plugging it in. So that's what we're going to do here. We take the number and we plug it in. Now, some of you may not remember how to evaluate this, but you have to, okay? So have whatever method that you need to and figure out what this is. Some of the things you can remember, maybe all students take calculus. Cosecant is the reciprocal of sine. So in the fourth quadrant, in this case, it's going to be negative. So this is negative, and hopefully you remember it's the reciprocal of sine. So in this case, 2 over radical 3. Done. Okay, part B, we're just taking that negative 4 and plugging it in. So square root of 4 is 2. Direct substitution, always try that first because it might be easier than doing some of the other stuff. The next thing, if you know a vertical asymptote exists there, then it's going to be does not exist, okay, or positive or negative infinity, but you can always write does not exist. So if we just plug in, do our direct substitution, okay, on the top we get 2, on the bottom we get 0. It's not 0 over 0, so that just tells us it does not exist. And technically in this case it ends up being positive infinity if you wanted to write that. Over here we would get pi over sine of pi, which is 0, again, does not exist. We have a vertical asymptote there. And in this case it ends up being negative infinity. But you can always put does not exist because infinity technically isn't a number. Limits at infinity, we just did that in the last video. We have a rational function. The degree in the top matches the degree in the bottom. So we just take the coefficients of each of those terms. So we end up with 5 over negative 4. Okay, this one, ln of absolute value of x. Ln of x, so we'd have ln of infinity, okay, so that's going to just keep getting bigger and bigger, infinity. Then we have the next one, a piecewise function. That's easy to figure out because it's in pieces. We have the limit of f of x as x approaches 2. Now remember, that implies 2 from the left and 2 from the right. So when you do this, you have to consider both cases, and hopefully they're the same thing. So limit as x approaches 2 from the left, that would be going into this part. So we get 4 minus 3 is 1. Limit as x approaches 2 from the right, that would be this part. Plug in 2, we get 1 plus 1, 2. 1 is not equal to 2, so this does not exist. Okay, another example, limit as x approaches pi. Not x is pi, x approaches pi. So in this case, we're technically only looking at this part. So sine of pi would be 0. The squeeze theorem, this sounds kind of complicated. It's also known as the sandwich theorem, but it's not. It's really, really simple. Basically, if you have something like this, you have a graph like this, and another one like this, and then you have some kind of function in between them, well, the limit gets squeezed in between the function. So if you have a function on the top, say this function, okay, that's the biggest, and you have a function on the bottom, and that's over here, that's the smallest, then you have some kind of function, this one, squeezed right in between them, or maybe even equal to them. Well, what happens is you take the limit as x approaches 1 of each of the outside functions. Ln of 1 is 0, 1 squared is 1. Take the limit as x approaches 1 on the other function, x minus 1. E to the 0 is 1, so limit as x approaches 1 of j of x equals 1 by the squeeze theorem. And it could also be called the sandwich theorem. Okay? So now we're going to have algebraic forms. If you plug in the numbers using direct substitution, you should get 0 over 0 or infinity over infinity. That tells you got to try something else. Okay, so the divide out method, if you do direct substitution, you're going to plug it in and get 0 over 0. Well, we got to try something else. So maybe factor. We have x plus 2, x minus 2. And on the numerator or denominator we have x minus 2. Cross that out, then plug it in. The limit equals 4. Okay, this one, hopefully you know how to factor x cubed minus 1. Maybe you don't. If you don't, you should try to learn how to do that, okay? Or quick little thing, do synthetic division, okay? I'll do that on the side. So we're going to divide these. So we have 1 x cubed, 0x squared, 0x, negative 1. Okay, we're dividing x minus 1, so 1 into that. 1, 1, 1. Wow, okay, so that was tough. So when you factor that, you're going to get x minus 1, and then you're going to get x squared plus x plus 1 over x minus 1. We're able to cross those out, and now plug it in. 1 plus 1 plus 1, 3. Okay, similarly, we can do synthetic division for the last problem. If you plug in negative 1, just go ahead and do it. If you plug it in, you should end up getting 0 over 0. So you know that there's some bad guy factor that you can divide out. Okay, if you don't know how to do that, well, that doesn't help, I guess. The bottom does factor, 2x minus 3 and x plus 1. My guess, since that's what we're going towards, is the x plus 1 is the bad guy. All right, so we have 1, negative 1, negative 1, negative 3, negative 4. Hopefully I'm doing this right. Negative 4, 4. Oh, I got 0, so I must be. So now we're taking the limit as x approaches negative 1 of x cubed minus 2x squared plus x minus 4 over 2x minus 3. Now plug in your number, negative 1. And you should get negative 8 over negative 5, so 8/5. And the last one for this video, rationalization or conjugation, RatCon. If you plug in 0 for the first one, you get 0 over 0. Darn, we have a problem there. But what we can do is multiply by the conjugate of the radical part. And remember, we can't just magically multiply by something unless it's 1. So if we take the limit, and remember to bring this down, it's a really good habit to get into. We get x plus 1 minus 1 on the numerator. Hopefully you'll see that'll cancel out with the x in the denominator. And I'm just going to leave this. Why multiply it out? The plus 1 minus 1, well, that's 0. X over x, that makes it 1 over this bottom function. Now plug in 0, and you get 1/2. Okay, I know this one's a little bit tougher, but I'd like you to do this for your whisk. Okay, a lot of people get confused. How do you know which sign? You never change the sign of the function inside of the radical. You always just change the sign here. So if we were going to multiply this by something, we keep that the same, x plus 2, and then we're going to have plus square root of 5. Okay, square root of x plus 2 plus square root of 5, because that is the opposite sign in between those two terms. So you try that, put it in your whisk, and I'll see you in class.